Okay, before the break, we were talking a little bit about software and a few other odds and ends, um, getting ready for follow along example of looking at some software development issues. And that's part of our lab this week. A question showed up in the chat room during the break about that. Is it okay to copy and paste the HTML code into text editor and submit that? And that will be fine. Any way you can get that to me will be fine. You type it in text editor. If you type it on rippleIT.com, the online IDE we're looking at, you can just send me the share link or share it with me, or there's multiple ways to share it. I think most people have seen that in our modern world. I'll point at the button when we get back to it. And another thing I was started to say, and then realized I should wait till after the break, is if you already know programming, I was saying earlier, if you're already familiar with programming, more is always acceptable in my class. So Dylan, you asked about working in Java, and so you and some of your friends have been learning Java. If you want to turn in a Java assignment instead of that Python one, I will be perfectly okay with that, because I know you're learning, and that's what we're here for, learning and progressing. I know some other people are currently working on learning video games and getting started into video game development. If you want to turn that in, that'll be fine. As long as you're developing software, send me a piece of software that you developed. That will be fine, right? Kind of relating to that copy and paste question. As long as it's your code that you're copying and pasting to get to me. Right? Don't copy and paste somebody else's code and send that to me. But yeah, any way you can get it to me is fine. If you want to do more or have some projects that you're already working on that you would like to send me, maybe you would like some feedback on them or something, that would be perfectly okay. More is always acceptable in my class. I probably should have been saying that since the beginning, because I know some people might have, some of those labs might be, I designed them for the introduction level, that very starting off point. So in our modern world, some of you might already know a lot more about information technology than those labs are covering. So more is always acceptable. All right, so back to our IDE. Has the tools we need to develop, test, and debug code. Debugging code's when we have a problem. So we printed out that test, the standard test, print hello world. Something I like to do in classes is throw error messages, because if you look at books and tutorials, they always show that nice, clean, finished product where it looks like everything came together smoothly. And anybody that's written code before knows that's not how it comes for us. We hit error message after error message while we're putting it together. So I like to throw those in the class examples and see that. So maybe we spelled the word print wrong. Maybe we put pint hello world instead of print hello world. Get some sort of message, a problem occurred. And in Python, this is what our problems look like. The error messages come as tracebacks. So what it does is the computer takes the instructions we wrote and it stacks them up. That's the actual name for it, is a stack, because of how we process through it. A stack is a last in, first out structure. A good example is like when you're after dinner, you go and wash your dishes and put the plates back in the cabinet in a stack of plates. And then for the next meal, the first plate that you grabbed to put food on was the last one that you washed and put away. So last in, first out. And the computer processes our code the same way. The last instruction to go in is the first one to get taken off that stack and ran. So we write our code from top to bottom down these lines, and the computer initially reads it in backwards. So that it reads it in from the last line back to the first line, so that the first line that we wrote is then the top instruction on that stack. And then it starts running them, pulls them off one at a time, runs that instruction. And if an error happens, it puts them back on the stack it puts a few things back on the stack and then kind of goes back through the last few instructions to figure out where that happened. And that's called a traceback. So it gives us information. So it happened in the main.py. We only have one file. We knew that part. On line 1, again, and at the point we're looking at this, we only had one line. So we kind of already knew that part. But somewhere in here, it shows us the instruction, and there's something wrong with the name in that instruction. Doesn't know what pint is. So we get those details. So when you're working through the lab or putting your program together, you want to look for those things. So you'll look for the line number it sends you to, and then the actual what the error is. And you're going to see a lot of those. We call that process debugging. Does anybody know where the name debugging comes from? Anybody heard the story?
Yeah, I think I do. Isn't it because back when they were making computers, like their first computer, bugs like were really interested in it, and a bunch would die inside of the computer?
There was one in particular. There was one especially, but that was a very common problem because they had vacuum tubes, so they put off light and heat. So insects really like light and heat, but one in particular. So I pulled up this name. I've been anxious to talk about this name. If you do not know the name Grace Hopper, as you're heading into IT, this is a name you want to know. So right off the bat, I was talking about all that stuff. Well, you can see her in her uniform. She's an admiral, right? A woman that made it to the rank of admiral back in the 50s and 60s. That's an indication of a very exceptional lady, right? Most of what we know, most of this, we can attribute to her. So ENIAC, the top secret project during World War II, she was one of the ones that, if that needed reprogramming, she would take it apart and put it back together. She built some of our first programming. She developed some of the first high-level languages. Definitely a name worth knowing. She had a lot to do with this, and yeah, a woman that made it to the rank of admiral back in the 1950s and 60s America. Should tell you, sort of an exceptional human being. But one day, on an early project, it was on a Harvard Mark III, or original debugging. And Jenna just mentioned the insects are attracted to the light and the heat on those vacuum tubes. I was going for the picture here, images. And it was a military project, so they put the code together. A lady like this in a room filled with other people that, really stand out, exceptionally brilliant people. They knew their code was right. They knew the machine worked, but they were getting an error and could not figure out where that error came from. So everybody else kind of took a break, and she took the machine apart to look for the problem and found that a moth that had gotten in there actually shorted out a circuit. The moth was like an on switch. It created a pathway through the circuit where there shouldn't have been one, so there was an extra one in there. But she took the machine, Harvard Mark I apart, found the bug, and it was a military project, and she was the military person on the project, so she was the one that had to write the report. And in her report, it's kind of hard to read here, she wrote, had to debug the machine. And that's the term that stuck around. I think these pictures of the bug taped to the report are in the Smithsonian behind a bunch of glass. Considered one of our very important documents in the world. But that's where that term stuck around. We have to debug the machine. Luckily, we don't have to take the machine apart and put it back together like she did, actually taking a bug out of it. But that term that she made up that day for her report stuck around. So we know what the error is, and then we go in and fix that little bug. And sometimes there's other issues. I'm going to talk about what this is going to do here in a second. We'll talk about what this is doing, but another thing about the error messages and bugs is on this one, it's kind of out of context, so I'm going to add a little bit of context here. It says the error happened on line 3. So we go to line 3, print hello world plus whatever is stored in this spot. We're going to talk about that in just a moment. And it can only concatenate strings. Concatenate is the verb that means put strings together. So we have multiple words like hello and world, and we need to put those together into a single sentence. That's our technical term for that. But it says the error happened on line 3, but the problem's actually up here because that's storing an integer, but we only needed to store it. We should have stored a string, the symbol 3, not the number 3. The one that goes in a sentence, the little, just the character, the way we draw it, and not the one we do math with. So with error messages, when we see that line number, the only thing we really know for certain is that the error did not happen after that line. So a lot of times it will be on that line, but the only thing we really know for certain is we don't have to look after that line to find the problem. It could have been that line or somewhere before that line. And the further back in the code it is, the harder it is to find. So I'll just add some quote marks in to turn that into we call it a string of characters. Basically our written language, the symbols we use in our written language. Our term for that is going to be string, and we indicate those by quotation marks. In Python, we can use single quote marks instead of double quote marks. Type the 3 in there, they're interchangeable, but not all of our programming languages allow those to be interchangeable like that. Sometimes the apostrophe, or when programming, we say single quote mark, is very different than the double quote mark. But for your assignment this week, they're basically interchangeable. Yes, the question in the chat room, if you want to type in another programming language, that will be okay. Replace the Python one with another programming language. If you want to replace the HTML one, I would still like you to do some sort of encoding. We talked about it the other day. Python's going to be our example of an imperative language where we're saying how to carry out a set of instructions, how to carry out each step. And HTML is going to be our example of an imperative language where the machine already knows the instructions. We just have to tell it which one we're asking for. So like an example of each. So you can replace the Python one with the Java one, or if you want to switch up the HTML, get a hold of me after class, and we'll talk about some other languages to replace that one with. But HTML is going to be very, very useful in our modern world, right? That's the language we write websites in. Okay, so now into that imperative language. I think I just said that backwards, didn't I? Python is our imperative language where we tell it how to carry out instructions, and HTML is our declarative language where we just declare what instruction we want the machine to run. So we need to tell it how to do stuff. And we talked about hardware. There's still a couple sketches, a rough sketch on the board to represent that. In particular, well, the file is going to be stored in storage, but we're going to pull it out of storage and send it out here on this picture and pass it in. And we're going to need mostly RAM, our random access memory, and our central processing unit to run that. So we need to think about those parts. So the first thing is we need to get some data into RAM to work with. And to do that, we create variables, which are not like the math class variable. In math class, the variable was the unknown, the thing we didn't know. When we go to store something in RAM, the computer is just going to remember a number. You say, okay, that's stored at bit 85,207. But a human's never going to keep track of that. We're an outsider to the machine. We need a different way to refer to it. Like your neighborhood. I think I talked about that example the other day. Right? If you're talking to your neighbors, you can give directions very differently than if you could give directions to, say, somebody coming from California trying to find something in your neighborhood. The outsiders and insiders need information differently. And we're an outsider to that RAM chip. So we need a better way to find stuff in it. And what we do is just assign a name to locations in RAM. So we'll make up some word. I'll call it pay rate. And it has to be one single word. So pay rate, I was gonna do a small payroll hourly pay calculator or something for our quick example as we talk about these concepts. So something meaningful, something that we will recognize what it means and makes sense for us. It has to be a single word, so that's 2 words. So I just jammed them together. And the way I wrote this is called camel case. So multiple words just jammed together. The very first letter is lowercase, and then each subsequent word would start with a capital letter to make that a little more readable. There's different ways. Some people like underscores to separate our words. Has to be a single word, and it has to start with a letter. And we can include some special characters, but that varies language to language. So for our purpose here, let's just say no special characters. So you can have letters and numbers, but you cannot have a number for the first symbol. You have to start with a letter, and then you can mix in letters and numbers to give it a name. And special characters are particular to the language you're working in, so let's just avoid special characters altogether at this point. You can work those in later. And that's going to be some number, which, like the name implies, is how much somebody gets paid an hour. So maybe somebody gets paid $23.45 an hour. Seems like a good, not a terrible hourly rate. And before we start doing some stuff, we need data on who's getting paid that much. So I'll store that in something maybe called employee, give it a name, and that's going to be somebody's name. So our written language, so we will need a string. Oh no, I'll say Sally. Seems like a good, I just made that up. It does not represent anybody. And notice when there was a number, something we're going to do math with, just type the number directly. And when we want to use the symbols, we include that with quotation marks. So I like to refer to a string as we're telling the computer quotas exactly on using these symbols, versus a number is like, use this value to do math. If the computer needs to translate it to binary to do that math with it, that's fine. It doesn't have to be an exact quota as long as it matches that value. But we want explicitly these symbols every time. So I like to think of that as quotas on that. What else do we need for somebody's pay? The hours they worked. I'll write that again. Hours worked is, I don't know, 37. That seems like a good work week. Almost, or yeah, that's full time. So that's enough to do the calculation. Maybe one more. Tax bracket. Yes, this is called there's actually two steps here. So a name about the terminology. So we're declaring that we have variables. So if I just said there's a variable here, that's a declaration. And then we're assigning it things. This variable is going to be assigned this value. And that is called defining it. Python is what's known as an open type language. So a question earlier showed up about Java. So if we were doing this in Java, we'd have to say, okay, we have a floating point number. I'm going to call it pay rate. End of instruction. So type in another language here for a little sidestep. And that's usually where we use the term declaration. We declare we have a variable, but we haven't put anything in it yet. And then when we actually do the assignment, then we've defined it. So in Python, we kind of combine both of them into one step. Great question. Which one of the many things about Python that's a lot easier. So we're going to declare this variable and assign it a value, which is an important thing. An equal sign, the equal sign here does not mean equals. Two equal signs means equal to or equality. But one equal sign means assignment. Some of our languages do that like an arrow. So that symbol would fit a lot better. That doesn't work in Python. But we're going to take the number 2345 and stick that into that variable. Slightly different syntax for each one. Oh, we need one more number to calculate somebody's weekly pay, right? How much do they pay in taxes? 2345 full-time is probably one of the lower tax brackets, right? So like 21%, somewhere around there. Not the lowest tax bracket, but making more money so the IRS wants a bigger chunk of it, which is much more complicated than 21%. It's actually like 14% up to the first 8,000, then it jumps up to 18% for the next couple thousand, then it jumps up to 21 for the money after that. So it's tax is very complicated. I'm going with the simple version here because we just want to look at the programming language. So now we can do our calculation. Let's say net pay. Again, we set up a variable and we'll assign that. Well, instead of our data directly, we'll use our data to perform a calculation. So here we just did all those declarations. So all we did was put that in RAM. We need to move that over to the CPU to do a calculation. And everybody knows the calculation for net pay, right? We're Americans. We know how to calculate what should be on our paycheck for the most part. The hours we worked times the amount we get paid for each hour. So we can use that variable. So pay rate times the hours worked. And yes, we could have just stuck those numbers right there directly. There are advantages because here in about 3 minutes, we're going to come back and replace this with an input so that we can get a different number and use the same program over and over and over again to calculate Sally's pay, at least until her next raise when we have to change what her pay rate is. But that only happens like once a year. We calculate somebody's paycheck every week. Oh, but then we need to figure out what her, how much taxes are going to come out. So I'll set up a spot over in RAM to store taxes and then pass it. Describe how to calculate that variable so the CPU will figure out what number that is and then store it in RAM where we put this number. Taxes are going to be the net pay times our tax bracket. And again, we could put numbers in there, but doing it with variables makes it a lot easier because all of our declarations and just the pure data assignments are up at the top. So that once a year when she gets a raise, all we have to do is go there and change that one number. Or if that raise pushes her up to the tax bracket, we just change this number. And then any places that we referred to that, any place we referred to that number changes refers to a reference to that number, not the number itself. So our reference would still be the same even if we change this value. At the introduction level, it probably seems a lot of times it'll seem like it was easy. It would have been easier just to put the numbers there. It's like, that's a lot of extra typing just to do some small calculations. But as things get bigger and bigger and bigger, that becomes more and more productive. It shows up a lot in software development classes. I'm all the time talking about things like, okay, yeah, we're in a classroom, we're under way too tight of time constraints to possibly see the benefit of these other tools that we have in our programming language. So for now, we just have to learn the syntax and the time we have. And when you get up to where you're working with tens of thousands or millions of data points, then you'll see when it's advantageous to do it, certain things. But that sort of stuff doesn't fit nicely in a classroom. Okay, back to our example. We had our net pay and how much taxes she owes from that. So now we have enough information to calculate what the gross pay should be. Net pay minus taxes. I always like these as starting examples because I think most people in America know how to calculate the numbers that should be on our paycheck, right? It's a very important thing in our lives. Oh, that gets down to the number that should go on the paycheck so we can do some output. And our standard output, which notice when I started typing, the predictive text kind of came up, so I could hit tab and select it off that list or scroll down just in case I meant to type one of those. And over here, we get a description of what it is. So the name of this method that we're calling, that's a pre-built segment of code that we can ask for as it's needed. And then what do we need to run it? Well, it needs to know what we want printed. And down here, we get a description. It prints the values to a system.standardout. The standard output in this case is our console. So print just sends the output over here where we can read it, which is what we need here at the beginning level, right? And what do we want to print? Well, really, we want to print gross pay. But I'm going to come back and make some adjustments to that. So I'll save that, which it saves automatically. I don't know why I'm in the habit of hitting Control S to save it, but it saves automatically. And you can see it cleaned up some of that white space where I'd hit enter a few extra times. We should be ready to run this. There we go. So now we see how big her paycheck's going to be for the week. Enough to get groceries and put some money towards rent and all that normal stuff that we need a paycheck for. But really, that's not very good output, right? If somebody came up to you on the street and said 685.4435, there's not much information there. That's data. That's that flow we keep talking about in this class, right? Data, the raw facts. Our raw fact is this number. We don't have any context for it. There's no context whatsoever. We need to turn that data into information, add some context. So maybe we add a $sign down here. So I'll add a string with a $sign right in front of it. And to concatenate two values, we use the plus sign. And some of y'all are probably well aware this is going to throw an error. Same error message we saw earlier. We'll talk about how to fix that now. Oh, well, we tried to get some context. It wasn't just 685.443. is $685. We have meaning to it. Can only calculate string and number. And this is one you will probably see in what you're doing this week. We have a string and we want to put that string together with a number to get output. So we have to cast that number into a string. And in Python, the way we do that is wrap it with another method. So we type str and then put parentheses around it. So str for string. So we want to turn something into a string. And then in parentheses, we say what we want to turn into a string. There we go. Got some context. We did that first step. The raw data, 685 could mean anything. But now if somebody runs up to us on the street and says $685.44, we'd have a slightly better idea what they're talking about, right? But it's still just that first step. And we have a couple other steps. How does that apply? What do we do with that $685? If $685 is coming to us, that's pretty nice. If we owe somebody $685, that's not so nice, but we don't know what to do with it yet. So from the data, our raw facts, which was just a number, but we added some context, turned that into to indicate that's money. Don't worry about rounding or anything. If what you do for your assignment on the lab this week involves money or something, just go ahead and spit out all the decimal places. That won't hurt anything. Rounding is a couple steps above where we're at currently. So we need a sentence here. So we can add some other words in here. So we say, well, whoever stored an employee data, which we know is Sally, but usually when we write software, we want that software to work for lots of people, right? We want that same software to work for everybody in our company. So in our example, we only put one name there, but in a larger piece of software, we would connect to the company database and just grab everybody's name and store it there as we work with it. Grab all this stuff about each individual employee from the database and run through the same calculations and then output what prints on the check. Or in this case, whatever's stored in that employee name field, which is a string, so we don't have to worry about casting like we did with the number. We don't have to turn it into a string. We already have a string. Employee, so Sally made this many dollars plus this week. Pretty nice little grammatically correct sentence. And did you all notice how I did that way out of order? I always like to make a big point in this in software. The computer has to have that code in a specific order by the time we get to the end. But that order the computer needs it in is probably not the order we think about it in. And it can be a lot more productive to just bounce around, right? We have a mouse, we can move our cursor anywhere in here and insert new text and edit things. So it can be a lot more productive to bounce around in the order you think about the stuff in, and it just needs to be in the order for the computer at the end. That can be a useful little thing. So we run this now, we get that useful little sentence. What happened? 2:30, okay. Casting goes the other way too. So if we had a string, I'll put that same one I had earlier. So X is the symbol 3, but we wanted to do math with it. Z is X times, or I'll do X divided by 2. If we want to do math with that, we're going to hit a similar problem to what we did here, only going the other way. Um, so it says the same thing, type error, but the last message said can only concatenate strings, and but here unsupported operand. We can't divide a string into an integer. Right? Math operations on our words don't make a whole lot of sense. So to turn that into a number, we would kind of wrap it the same way. Only instead of, whoops, up here we wanted to turn a number into a string. So we put str and then said what number. Down here, we want to turn a string into a number. So int for integer, or float, float for a floating point number. What we would normally call decimals, the ones where the little dot moves back and forth to whatever spot it's needed in. So there's some stuff about casting, kind of goes both ways. You see we get that division. Let me turn that into an end. Notice on the division, if we do 3 divided by 2, we get 1.5. That can be useful sometimes, but other times we might want something else, like the quotient and remainder version. We use bigger numbers. 17 divided by 3. 5.66666666667. I think everybody recognizes that's 6s that repeat forever. So the computer can't write it, so eventually it just rounds it up and writes the 7. But so that's not really what that number is. That's an approximation of that number. Would be a lot better if we had the quotient and remainder. And to do remainder division, you'll do 2 slashes. So that'll give us just the integer portion. So we just got the 5. And I'm going to change that to a better name. So quotient and remainder is, well, again, we'll turn x into an integer and do that mod 3. Modulus is an operation you probably haven't seen much. It shows up very, very heavily in modern mathematics and higher level mathematics. There's a really useful little trick. Before the days of calculators, it was more important. Before we had machines that would do it. But if we divide everything, if we have a bunch of big numbers, like trying to do astronomical calculations or something, if we divide everything by the same number, we can work with the remainders and get the same, and get back to the same answer we would have working with the really big numbers. So we can just divide down, work with the remainders, and then we have nice small numbers to work with. Doesn't show up as much as, not as important as it was before the days of computers. But sometimes we want that remainder, like 17 divided by 3 gives us a decimal that repeats forever. So we can't actually write that number down. So to get it accurately, we would need the quotient and the remainder. And print that out nicely. That is quotient with a remainder of remainder. And this is, again, with that jumping around thing. I put the whole sentence together, but these are numbers, so I need to do the same thing I did up here. And let me see if this works. str, instead of type in parentheses, I'm going to highlight this. In most of our text editors, anytime we type an open parenthesis, we need the closing parenthesis afterwards, right? Well, computers know that. So usually in most of our decent text editors, the really cheap one that came on your operating system, like Notepad or Text Strangler, probably wouldn't, but any decent text editor would know that. So if we just type the open parent, if we highlight it and then just type the opening parentheses, it'll go ahead and put the closing one on for us as well. Same thing with square brackets and the curly braces and angle brackets and a few places, but for y'all this week, probably the parenthesis one. So we'll type that first part. We want to turn into a string this thing, and instead of typing it, I'm going to hold shift and use the arrow key to highlight that word, and then just type the opening parentheses, and it'll put the closing parenthesis on there. So a couple of things. The addition, the plus symbol is overloaded. We can use plus in math. That one's left off here, but since you see subtraction, I assume you'll be okay with plus. But it's what we called overloaded. We went ahead and assigned more than one value to the plus symbol. We can use it to add two numbers, which we didn't do here, but hopefully y'all can figure out how to add two numbers from what we saw here. Or we can use it to concatenate two strings. We can add two words together to make a sentence or a phrase. Add a bunch of words together to make a sentence. And that's how we develop the instructions in imperative languages. We spell out what to do on each step. Put this number into RAM, put this string into RAM, put this number into RAM, put this number into RAM. Grab those numbers from RAM, do this calculation, and then put the result of that back in RAM. I'll grab these two numbers for RAM, do that calculation, and stick the result of it back in our RAM chip. Grab these two numbers, do that calculation, and stick the result back in RAM. Now, grab these numbers, or grab these two things from RAM, do this little adjustment here so that everything is a string, concatenate all those strings together, and then spit that out on our screen, on our monitor. And see how we're explicitly telling the computer how to do these things. Versus HTML, where we just put in that tag, like a little tag that said P, and it wrote the text out there as normal paragraph text. Or we put that tag there that said H1, and it wrote that text out as great big bold letters. Those instructions, how to carry out the instruction is already spelled out, so we just had to declare which instruction we want. And that's our two main types of programming languages. We're going to look at an example of each. I think the other thing we need to cover is, well, this software seems to work for Sally. In a larger example, we would have a big database filled with all our employees, and we would just grab these one at a time, right? We grab Sally's name and pay rate and hours worked and the tax bracket. Then we do all this. Then we come back and grab, making up another name, grab Becky's pay rate and name and hours worked and tax bracket, and then run all these calculations. And we do that for every name in our database. For example, there's probably one more thing, is Sally's first name's not going to change. Her last name might change. That's another point I always like to point at, express in software development, is remember that women regularly change their name, right? Women, or anybody can change their name, right? We're perfectly allowed to, but it is very, very, very common for women to change their name. They're going to do that when they get married. And Ivy Tech is a great example of that. It is very, very difficult to get your name changed in the Ivy Tech system. So if Ivy Tech knows you by your maiden name and you get married, your email, Ivy Tech email is still going to have your maiden name. Your login stuff, a lot of the paperwork will still have your maiden name, because whoever programmed it did not account for the fact that women get married and change their last name. I've only in the, I could go all the way back to when I came to Ivy Tech as a student. I've only ever seen one person successfully get her name changed through the Ivy Tech system. And she went through a lot. She ended up driving to Indianapolis several times to do it, but she was very, very determined to not use her ex-husband's last name. she was absolutely certain that she didn't even want to see his name written down by her thing. So she had to make several drive up to Indianapolis several times and sit there with the main IT people to get her name changed in the system. So if you're heading into software development, please remember people change their names, not just their usernames, and work that in from the beginning. But for our purpose here, it's not going to change. She's still going to be called Sally. That's going to change every week. But we did the simplified tax version, so our taxes aren't going to change. So really the only thing that changes is this number right here. So instead of typing that in directly, why does that keep rebooting? Can you all still hear me on the Zoom call?
Yes.
Okay. I don't know why the IDE keeps rebooting. I was just making sure I wasn't losing connection or something. Yeah. So the only thing that's changing is how many hours she worked. And obviously that's going to change every week. So instead of typing that in, this software would probably be a lot better if we got that from somebody. And our keyword for that, just like we have the keyword for print down here to get the output, is input. So it's like input, and then the little prediction that comes up there, which went away on me, input, and then in parentheses, it's expecting some sort of prompt. So it wants a string or a sentence to give to the user to let them know what input we're waiting on. Read string from a standard input. New line at the end will be taken off of there, so don't worry about hitting the enter key. What we get from the enter key is going to be removed. The prompt string is printed to the standard output with a trailing new line before reading input. So it's going to print out a prompt to let the user know what we want. I don't know. I'm changing it up. I do a lot of prompts and little examples. I'll do the cheerleader example this time. Cheerleader prompt this time. Give me the hours. Some of your instructors, make sure you know what your instructor's doing if you're writing code in other courses. I see a lot of prompts, so I change those up, have fun with them. Things, the cheerleader prompt, or like 1920s mobsters slang prompt, or use different things. But some of your instructors will be very strict on make sure it's a grammatically correct, polite sentence and all that. But yeah, I see a lot of prompts, so I change it up a little. So have fun with the prompt in my class. Just remember, keep it classroom appropriate. So we'll ask for that. The user will type something, put it in here, and then we need to do some work with it. But there's a slight problem there that we've already seen. You may notice what that problem would be. We ask the user for the hours, and they go type that on the keyboard. And we stick that over here in RAM. Then we do math with it. But on our keyboard, is that the number 3 or the symbol 3? Yeah, the keyboard's sending Unicode. That's the symbol 3, not the number 3 that we can do math with. We can't do math with words. So just like we did here, where we had to turn a number into a string to get it into a sentence, we need to turn a string into a number. Yes. I was going to do something slightly different in the chat room, saying cast it as an int like we have down here, which would work, but I was going to do something slightly different because an int just truncates. So if you worked 37.5 hours, it would cut that down to 37. Yes. So people would be very, very unhappy if that paycheck is missing that extra half hour, right? So we want to get to the right moment. So we want to turn it into a floating point number. And for that, it's just the word float, and then highlight everything we want to wrap in parentheses, and all we have to do is type the opening one and it'll wrap them. Again, notice how I put that together from the inside out. My first thought is, what's the prompt the user sees going to be? Then get the input value, then turn that into a float. The computer needs it in this order, but that's not the order I think of it in. So it's far more productive to jump around and put your code together in the order you think about it in. So now this works over and over again. We'll ignore that part at the bottom because that's just some extra stuff. So that when I send this to you in a few moments, they'll know what to do with it. Y'all can look back at this afterwards and while you're doing your examples. So give me the hours. So maybe this time she worked 32 hours. And Sally made $592.86 this week. And yeah, ignore that other stuff. I guess comments, there's code that doesn't do anything. I rarely make a big deal out of these. So other syntax example. The main example didn't include the syntax of everything I wanted to show. So maybe more syntax example. So now when it runs, there's this line of text that the Python interpreter will ignore because it's not Python code. Those are comments. We can put little things in here, but I usually don't make a big deal out of those. If you want to include it, put some labels for your own reference. They can be very, very useful as you start out, and put some English style notes of what's going on so you can keep track of things. But that's a line of text that the computer is going to ignore and run the Python code. So there's absolutely nothing that stops us from going the other way too, right? Where we ignore the Python code and only look at the comments. So we can do things like generate an entire website in the comments while the program's running. Is a very common one. Python has to do, whoops. There's some special comments we can put in here called annotations at to do. Just at to do. This makes a to-do list. So that at symbol is a special type of comment, so that this is one of the ones where it'll ignore Python code and compile a to-do list for us. And then we can just ask the computer for the to-do list and it'll tell us everything all the stuff we mentioned there. Or we can generate entire websites from the comments. I usually focus on those a lot more, where our comments do stuff as well. Because if this is just ignoring this text to do the Python code, we're perfectly capable of going the other way and ignore the Python code to only look at the comments. And then we can do two things in the same file. The comments can probably be useful for you all. Make little notes about what you're doing to help with the learning process. So we got that, but now our software can run repeatedly. Another week passes. How many hours she worked this week? So maybe she worked 43 hours. Get that number. That's a little bit off, right? That's going to be my first suggestion to you all. Copy and paste this code. And if you weren't following along, hopefully you were following along. Because if she worked 43 hours, she should get some overtime pay there, right? So see if you can work that overtime calculation in. This is an active subject. We learn by doing. So that'll be a good little calculation here. You could work it into one of those lines, or you can make add it as a new line. And think back to computers are doing small, simple things, right? All those ones and zeros. It either does something small or it does not do that thing. So lots of simple calculations that just build up to a big complicated thing are much better for the machine than trying to do one big complicated calculation in one line. It's also a lot easier to fix problems in when they show up in there. But every week passes, get her paycheck. I'll leave it to you all to work that overtime calculation in there. The standard is time and a half once you pass 40 hours. Make regular pay for the first 40 hours, then time and a half for the next 40 hours. This is an example for y'all to use, and we're on a cloud thing. So if you really want to, the download button is right here. You can download your files. I think you can just right click on this. Oh, yeah. Since it's only going to be one file, you can right click and download, but it's a cloud thing. So there's the invite. So you can just create a link to look at it. And copy that link and send that to me. I'll put this one in the chat room so y'all can look at that. Since other people might look at it, please don't change the original here. Just open it up and look at it. Unlike Google Docs, I can't share a view only. So when you click that link, you will have edit access. And can somebody click on that real quick?
I'm in right now.
Okay. Yeah, so you see up here, Dylan and Esther are on here. We have a chat room down here, kind of like Google Docs. We can see where things are. So if you want to work with your classmates and put stuff together, that's even better as well. This is a great thing for that collaborative work. Lots and lots of tools here. It is very much an active subject. Yeah, so you see we have the chat room, all our standards. Yeah. And if you want to add stuff at the bottom, go right ahead. But since other people might look at it, please don't change the top part for the syntax example, and just have at it. Practice those sharing things. Check out the chat room. Features you all are probably well aware of, but that way you can look back at that and see what's going on with it.
Go back over how to get into that room or how to join that.
Oh, I put a link in the chat room. Do you see that? Was that Stephen that asked?
Yeah, thank you.
Okay, yeah. So under invite, up there in the top right corner, there's a button that said invite, which was probably behind the Zoom thumbnails. I should have thought of that. If you move your Zoom thumbnails around, you'll see that, and then you can copy a link or do the restricted sharing to just a short list. I always go with the links myself. It's much easier that way. And then work on it in Teams and things like that. Talk about it in the chat room and learn to code, but it's an active subject. We learn by doing. So now is a great time to do it. My first suggestion is make a copy of this if you didn't follow along and fix that overtime issue. Maybe add it, then maybe extend it up with add it for other employees where you're asking for their name and rate of pay. Maybe assume everybody's on the same tax bracket or something. Everybody in the company is probably around the same, roughly the same pay usually, but add some other inputs in, fix that output, and start doing stuff. Does anybody have any questions about that? Okay, I assume the silence means no questions. I was also going to look at terminals briefly because our assignment this week is fairly trivial. It's the last of those foundational assignments, and making sure you can organize things nicely in a folder. Try to learn something new. I was wanting to look at the terminal and talk about this some, so I think I'm going to push that back to next week. So if you want to hold off on the foundational skills assignment, the making the folders and doing it in a terminal, no matter what system you're on. Is it Control 5? Yeah. Windows, Ubuntu, Kali Linux. What else do I have here? I have a bunch of them. Oh, Git Bash. I have a bash shell running my Windows system as well, or the old command prompt. I have lots of these. This is the operating system control language. These are how we go in and access that kernel directly. So from that onion picture, much more direct access here. That went a little longer than I was anticipating today. So we'll look at this next week If you want to wait off on the foundational that foundational skills of putting together folders, that's a great way to start with those. Terminal on a Mac. If you're a Linux user, you're probably already well aware of that. But that's the programming language for operating system control, where we access that kernel directly. And no matter where you're heading into IT, you're going to want to learn that. So this class gives us a good space to get an early start on that. And it shows up in the networking assignments next week. So it's probably a better time to talk about it next week anyway. And give some Python code stuff a practice. Some practice. It's definitely a learn by doing sort of subject. But otherwise, unless anybody have any questions, that'll be it for today. And our brief introduction to software, because that operating system control is going to be overall useful. We'll see it next week in networks. 3 weeks from now when we look at virtual machines. And you can put off the foundational skills assignment of making folders till afterwards, because that's one of my recommendations for doing that assignment. But as long as you learn a new way to put folders together is what I ask on that one, because I think most people know how to put folders together, put together a directory structure. Otherwise, I'll see you all next week. You have a great weekend. If you have any questions, let me know.
Thank you.
Okay.
Have a nice weekend.